It is time to learn about solving equations with radicals. So here we have our steps to solve an equation that contain a radical. Sometimes it may have more than one radical. We're going to get the radical by itself, and we're going to have everything else on the other side of the equal sign. So it's going to be a square root, cube root, something like that, and everything else is on the other side. We're not even going to have a number in front of that square root, cube root, fourth root. So 2 square roots of x, we don't want the 2 in front of the square root of x, we just want it to say square root of x. Then we're going to use that index. We're going to figure out that index, because that index is what we're going to need, and that's what we're going to use as an exponent to raise both sides of the equation to. Once we do that, then we'll be able to solve for x. Sometimes when you do that, you'll still have another radical left in the equation, so then you have to repeat the first 3 steps, so that you're then taking whatever radical you have left and getting it by itself, and then repeating that process before you can then go into solving for x. Our focus will not be on those, so that's why I have that in a different color. I have it there for completion, but understand those are not our focus. When the ones we're looking at, once you get the radical by itself, you raise it both sides of the equation to the power of your index, you'll be able to clean up that radical. Then we can solve for x or whatever variable we have, and then we're going to have to check for something called extraneous roots or extraneous solutions. They're just extra answers. Sometimes by taking, and this is mainly with our even indexes where we're raising it to an even power, sometimes we generate extra answers. And so we have to actually check our answer to make certain it's good. We can't just assume that, okay, we didn't make any mistakes in our steps, so we're good. Nope, you have to check. Then I put some recalls on here. If I take the square root of x and square it, I will get my x. If I take the cube root of x and cube it, I'll get my x. I have 3 of something and that I need 3 of, I get whatever was in there. 2 of something and I needed 2, I get whatever was in there. So that's the idea that we're using when we're solving the radicals, the equations with the radicals. So that's why we make the index match the power. The index match the power. So we can get whatever's underneath there out. Another thing we need to remember is that when we had the square root of 4, that was 2, but the square root of negative 4 was not a real number. So we're going to have to be careful for that, with that, okay? Another thing is that if I'm doing the square root of 4, it's just a positive 2, and it will not be a negative 2. Square root of 4 is a positive 2 only. It's not equal to a negative 2. So those are things to keep in mind. We are going to learn how to clean up the square root of negative 4. But for now, when we're solving these radicals, we don't want any negative square roots. Not yet. Not until we learn how to deal with them. So we're going to look at about 4 examples. So the first one says, well, all of them say solve the equation. And the first problem is the square root of 2x plus 2 equals 0. The very first thing I'm going to do is get that square root by itself. So that means I need to subtract 2 from both sides to get rid of the plus 2. That's right here. So square root of 2x plus 2. I'm going to subtract 2. On both sides. That will leave me with the square root of 2x equals negative 2. Now right here, I already know I'm done. There's no way to take a square root and get a negative number. So right here, I know this is not possible. I'm going to say no solution. It's a square root. Even index, taking an even index will not give me a negative number unless there was already a negative in front of that square root or that fourth root or that sixth root. whatever even root it is. I don't have a negative in front of that. I can't get a negative answer. No solution. If I don't catch that, and make a little note there for that no solution, you have an even root equal a negative number. If I don't catch it, when I go to square both sides, radical by itself, I need 2 of something because that's my index. I have 2 of something now. It gives me a 2x. Negative 2 squared is a 4. Then I divide both sides by 2 to get an x equals 2. If I try to plug that in and do my check, I will have the square root of 2 times 2 equals a negative 2. Because I have to check. I'm sorry. Not equals a negative 2. Square root of 2 times 2 plus 2 equals 0. Because when I do my check, I go back to the original problem. That's going to give me 2 plus 2. And that's not the same. So if I check my answer all the time, if I messed up and I didn't catch that up front, I'll catch it on the back end. And number 2, we have the cube root of 2x equals a negative number. This one's okay. So that one was, you had an even root. This time I have an odd root. Cube is odd. I can do that. We looked at the cube root of negative 8 and saw that it was negative 2. So that's okay. My index is a 3. So I will raise both sides of my equation to the 3rd power. So the cube root cube will just give me that 2x under there. And a negative 2 cube will give me a negative 8. Now I can divide both sides by 2. And x will give me negative 4. If I take my negative 4 and I do my check, I have the cube root of 2 times a negative 4 equals negative 2, and that's what we're checking. And the cube root of 2 times negative 4 will give me a negative 2, so everything will check out. I'll have negative 2 equals negative 2. So here's our third example. The square root of 2x minus 3 plus x minus 3. Our square root of 2x minus 3 is our focal point. It is not by itself. So I have to move the plus x and I have to move the minus 3. I'll move the plus x by subtracting x from both sides. I move the minus 3 by adding 3 to both sides. And instead of doing that in 2 steps, I'm going to go ahead and knock it out in 1. So I end up with the square root of 2x minus 3 is equal to negative x plus 3. Now that I have the radical by itself, I can square both sides, and I'm picking a 2 because my index is 2. So the square root of 2x minus 3 squared and the negative x plus 3 squared. So the square of the square root will give me just the 2x minus 3. On the other side, I will have to write that twice and multiply it out. A negative x times a negative x will give me a positive x squared. A negative x times a plus 3 will give me a negative 3x. 3 times negative x will give me negative 3x, and 3 times 3 will give me 9. On the other side, I'll copy down the 2x minus 3. Combining like terms on that right side, I'm just copying down the left, but on the right side, I will combine like terms. I have a minus 3x. I can put with a minus 3x to give me a negative 6x. So x squared minus 6x plus 9. So I've cleared the radical. I've cleaned up both sides individually. I don't have any other radicals. But I haven't solved this for x. See how you have a square on your x? That means I want everybody on one side, 0 on the other, so that I can try to factor to solve. So I will end up subtracting 2x from both sides. When I subtract the 2x from the 6x, that'll give me a negative 8x, and the x squared plus 9 copies down, and the negative 3 on the other side copies down. Then I'll move the negative 3 to the other side by adding it. Nine plus 3 will give me 12. So I have 0 equals x squared minus 8x plus 12. Now I need to try to factor that. That will factor to x minus 6 times x minus 2. There's a 1 in front of the x squared, so I focus on the 12. I need factors of 12 that add to give me 8, in particular negative 8. 6 and 2 are factors of 12 that add to give me 8. So if I make both of those negative, I get a negative 8. So now I can do x minus 6 equals 0, x minus 2 equals 0. Solving each of those will give me x equals 6 and x equals 2. I will have to check. Let's come on the other side and do our check. When I check my x equals 6, I have 2 times 6 minus 3 plus 6 minus 3, and I'm seeing if that's equal to 0. So I've taken the 6 and I plugged it in for x in the original equation. From here, I can really type all that in my calculator. I go to my square root, so second x squared, make certain there's the parentheses there, then do 2 times 6 minus 3. Close that parentheses, then do plus 6 minus 3, and hit enter to see if the 0 matches the 0 on the other side. And it doesn't. Now I don't have my calculator out. 2 times 6 is 12. 12 minus 3 is 9. Square root of 9 is 3. 3 plus 6 minus 3 will end up giving me a 6. And that 6 is not equal to 0. And the answer is no. So that 6, that's extra. X can't equal 6. I need to check my x equals 2. If both of them do not work, I may have a mistake. So if you have multiple answers, one of them should work out, or you may have a mistake, or you just overlooked something early on where it could have been like that first example we did. So it is possible, but it's just, I need to just make certain I really didn't have a mistake in there. So now I plug 2 in place of x in the original equation and type this in the calculator all in one to see if the left side matches the right. So here's your square root, which is second x squared. Make certain that parentheses is open. 2 times 2 minus 3, close your parentheses, then do plus 2 minus 3, and you should get 0 equals 0, which is what we need. So only this x equals 2 works. When we square both sides, we end up creating an extra answer. And you have to really watch for those when it's even. So when you a 2 or 4 here, that's where you really have to watch for those extra answers. Our last example has 2 radicals. It said get a radical by itself in the directions and the steps. So I only need one of them by itself. It really doesn't matter which one I pick. I just need one of them by itself. I will not pick this second one because the second one has the negative in front of it. If I pick it, I will then have to divide both sides by the negative to get rid of the negative. If there's a number in front of your radical or a negative in front of your radical, you have to divide both sides of the equation by that number or that negative. Make a note of that. If your radical has a number or a negative in front of it, you will have to divide both sides by either that number or that negative so that you can get the radical by itself. Because again, by itself means you can't have that 2 in front of that square root or that cube root. So on this one, I can pick either one. But I'm going to make it easy on myself, and I'm going to keep the one that has the positive in front of it with no number here, and the one with the negative is the one I'm going to move. So when I move it to the other side, I'm adding it. If I add what's here, that'll move it from this side and it'll put it on the other side. So now I have the cube root of negative 4x minus 3 equals the cube root of negative x plus 5. My index is a 3. So I raised both sides to the third power. And when that happens on this one, something nice happens. The cube of a cube root, I just get that middle stuff. I have 3 of it. I get negative 4x minus 3. And that's what I have on that other side. I have the cube root of a cube. So I just get negative x plus 5. If there was a number in front of that cube root, then I would have to cube that number. So if there was a 2 right here, I'd have to do 2 cubed. Then do the negative x plus 5. If there was a plus or a minus, something plus this or something minus that or that plus something or that minus something, then I would have to FOIL it out. So this one worked out nice for us in that both radicals disappeared all in one swoop. So now I just need to solve for x. I don't have any squares or cubes on my x's, so my goal is to get all the x's together and then start plucking everything away from it so that I can get x by itself. I'm going to just move that negative x to the other side and make it a plus x. So minus 4x plus x will give me a negative 3x. I'm adding the x to the other side. So negative 4x plus x gives me negative 3x. Now I'm going to take that, subtract 3. I'm going to make it a plus 3 so that I can get it on the other side. So negative 3x will equal 5 plus 3 is 8. Now I can divide both sides by 8. I said 8. I do not want to divide both sides by 8. I want to divide both sides by negative 3. And I'll have x equals negative 8 over 3. This too I need to check. And again, I'll put everything in the calculator using my parentheses in one big swoop. And I will end up getting 0 equals 0. And my answer will check out. And